My name is Jalen Francis, and today I'm going to be demoing a decentralized voting system that I created. This system has a GUI, uses multi-threading, blockchain technology, and a secure login system with hashing, including salted hashing for the passwords. So I'll go ahead and demo it. So first, I'm going to go ahead and open up the app. So first, as you can see, we're mining the Genesis block, and since we're using hyperthreading, you saw that the CPU ticked up to 257%. Now it's very low, the CPU usage, since we're done mining for now. But we can go ahead and pop open the view of the blockchain. So the very first block is basically just the Genesis block. Right now, the number of required zeros I've defined is 3, and that's out of 32. So rather than dealing with the individual bits, how many bytes need to be 0 for us to consider our proof of work complete? So here, as we can see in hexadecimal, there's 6 zeros here. So as we can see, we have met our proof of work with the first Genesis block. And so now we're going to go ahead and register to vote. Right now our database is empty, so we don't have any accounts to log in. So first I'm going to go ahead and make an account. First, the username and password, you have to enter something for both. So we go ahead and we call this just demo password. As you can see right here, we can go ahead and submit it. We're now registered to vote. So if we go back here and enter in the same info, if it's wrong, authentication failed, but then it takes us to the voting screen. So just for the sake of the demo, we're going to consider 2 candidates. Let's just say Jimmy and John. So this person is going to go ahead and they're going to vote for Jimmy. So yeah, so first we got to go ahead and mine the block. So yeah, it counted the vote, and we can go ahead and view the blockchain, and it's on there. And if we go ahead and view results, we see Jimmy has 1 vote. So let's just go ahead. We're going to create Abby, let's say password 1. Go ahead, vote password 1. Okay, let's just say the person votes for John. Okay, so we went ahead and mined the block there. And so as we can see, Abby voted for John. So we have John and Jimmy. If we view results, right now they're even. If we go ahead, create a new person, let's just say Aaron. And this will be, we can say password 2. You are now registered. Aaron, password 2. And we're going to go ahead and have Jimmy get another vote. So let's go ahead and cast the vote for Jimmy. Okay, so the vote's now counted. We'll go ahead and view the blockchain. And we can see it got updated. And as you can see within here, if you look at the hashes, this has 1446, previous hash 1446, and so on. And then we can go ahead and generate a nice looking website. And we can go ahead and view the results. And as we can see, Jimmy is winning. So yeah, if you want to view the website generated, that will be in the website folder at the top of the directory. And we can go ahead and see demo Jimmy, all the hashes, all the data. There's timestamps for everybody. Now I want to show you guys on the back end. If we look at the actual database, how the passwords are stored, we have the name, and then we have the actual salt that's randomly generated, and then the corresponding hash associated with it. Okay, now on the actual back end, we have here's our blockchain, and so we have a mine block method that's pretty much called. Basically, this is where the threading actually happens, and so there's an additional method that basically compartmentalizes it, and then method to create the Genesis block, add the block to the blockchain, create the blockchain. This is our check is valid. It might be useful to actually see the headers since these actually have some comments in there. And we have a right to website, a free blockchain. But yeah, is valid block is basically just testing to make sure that the indices are right, making sure the actual hashes of the blocks are good, and make sure that we don't have any users double voting. Within our hashing script, this is basically just my own implementation of the SHA-256 cryptographic algorithm. Here we have our user manager, and we have a method here to go ahead and generate the salt in the load user database. We pretty much use a unordered map throughout, and then we have a pair for the actual salt, the password like after the hashing with the salt, and that's basically all stored into there. So when we're loading the database, we're storing all that. As you can see, salt and then hash password. When we're saving the user database, is basically just iterating through and just writing in the same format. When we register a user, we make sure that we go ahead and put the password, create a random salt to it, generate the hash for it, and then store it back into the user database. And then to actually authenticate a user, we pretty much first check that the user is in the database and then salt the password that they put in and see if it matches. Yeah, next in our voting counter, we have an add vote method, and basically we go ahead and create a new block for it, and we check to make sure that the block is actually valid. And if so, then we add the block to the blockchain and then add it to a set just so we know who has voted, just to make verification a little bit easier, as we have a check if voted method. And then we have a method that basically just inserts it. And then finally, we have a method to go ahead and tally and sort the votes. So yeah, overall, I think that about covers it. We can go in a little bit more detail. Like here is actual required zeros. So if we change that to a 2, go ahead, remake the app. And if we open that, we'll see that the actual blockchain processes a lot faster. And there are only 4 zeros in the hexadecimal format. Or in other words, the first 2 bytes are zeros. So yeah, we can go ahead and create some new people. Let's say Brian. I'll just name it password. And we'll see that the actual hashing is a lot faster. So if we, or the time it takes to pretty much mine in the blockchain, see it was basically instantaneous. And if we view the blockchain, still same format. So it's a very easy constant to change depending on what difficulty, what machines you're running, how secure we want the blockchain to be, how much time we want to overlap. So yeah, I think overall this just about covers the app. If you have any recommendations, feel free to let me know. My email is listed on my website at jalencode.com, where you can find more about me and the project. Overall, some recommendations is that this blockchain is pretty much personal to your own computer. So there's no actually good system for multiple people to run the same blockchain. And also, I think in the future, we could implement so more names can be actually added to the voting system. Overall, just feel free to branch off this code, do whatever you want, but that's all. See ya.